Now that our project has grown considerably large, it's now time to step back, look at the big picture, and perform optimizations if possible, especially for this project since it was originally created as a course material. Here are the optimizations that we have performed on our project. Introduce common libraries to do the mapping from entities to DTOs and vice versa. We are using a Java library called mapstruct. Refactor common classes into a new project. Create a new project, rootcamp commons, that contains the base models, DTOs, and base classes for the API. And here is that base project, the rootcamp commons. It is available in the GitHub repository, which I will share in the description of this video. Like I mentioned earlier, we have our common model classes in the rootcamp commons. Rootcamp DTOs contain the DTO common or base classes, and then the base API classes, which is rootcamp API. It contains the base classes or abstract classes that we will be extending for a service, repository, and the REST controller. For instance, the abstract controller, which will be extended by most of our entity classes or REST controller. It contains the basic CRUD operations: create, update, find all, and delete. So we don't have to implement them one by one on each of the REST controller. We just have to extend them. And then we also have the generic mapper, which is this one. It converts, so this is the one that is using the mapstruct. It converts an entity to DTO and vice versa. We also have the assembler, which add links to the response. Hate OAS links to the response object. So currently, this is the structure of our project, of our classes. For entities, we have the base entity as the base parent of all the entities, and then auditable entity, enable entity, business entity, and category. And then there's a one-to-one correspondence to the controller and the resource assembler. And then I extracted some of the most common functions, methods into abstract controller because maybe later on we will create another controller that doesn't need the CRUD operations from the abstract base controller. Let's check that abstract base controller. It contains the initialization, what entity class is being managed by this abstract controller, init binder, init page. So basically, utility functions that we might use on controllers, not limited to the hierarchy that we have here. Number 3, standardize the configuration. Right now, we are using bootstrap.properties and application.properties. The application.properties can be copied, pasted, and modified into the local Git repository where the Spring Cloud config project is pointing to. The application properties in the project can be removed, such as, for example, the TerraWarehouse catalog. We have the bootstrap, which will be loaded first, and then it will check this URL for the configuration. But since I'm testing locally, I also have the application properties inside the source main resources. So if I don't have any property file in the local Git repository, this project will use the application properties located here. But if you decide to have different configurations for different profiles, then you can use the config server, and then you can copy this and paste it there and then modify the value. For example, if you want to use a different port, you can modify it and then commit in your local repository. Why I'm now using application.properties? Because it's the one supported by Spring, and I think it's the current standard, although YML file is easier to read and it can be converted into a class. But for now, we will use Bootstrap and application.properties file. Number 4, introduce new projects. Right now, we have added the Terra Warehouse inventory. It's a project following the CQRS architecture that mainly deals with the inventory of the products. Here, we expose a new API for adding new stocks and perform exception catching as well. And then we have the Terra Warehouse Gateway. It is an API composer project that calls the other microservices to perform an action like get all product stocks with the product stock details from the inventory service and product code from the catalog service. These two projects are also available in GitHub. Right now, this is how our project's architecture look like. We have the Terra Warehouse catalog and the Terra Warehouse inventory fetching their configurations from the Terra Warehouse config server. And then both of them registers to the service discovery server, Eureka, as well as the Terra Warehouse gateway, which we will discuss later. In the previous video, we have also configured a Terra Warehouse load balancer project, which is running or powered by Zool, and we can access these two microservices using the load balancer through Eureka. Remember, we don't need to know the actual IP of these two microservices. We just need to create the proper routing in the Zool load balancer. Later on the succeeding videos, I will create a test on how we can call the services we have here. Additional changes. We have enabled the actuator on load balancer project. Thus, routes endpoint is now available via the HTTP localhost 8267 actuator routes. GitHub codes are available under this or on this URL. Again, thank you for watching. This video will serve as a refresher so that when we continue with the rest of the videos, when we are creating our API composer, we will be familiar with how our project project's architecture. Please do subscribe to my channel and hit the bell icon to get notified when I upload new video. See you on the next one. Bye.